Hello everyone, this is a video for Lesson 2.1a, Transformations of Quadratic Functions from Algebra 2, Big Ideas. Let's take a quick look at our learning targets for the lesson. So after the lesson, you should be able to describe transformations of quadratic functions, and you can graph transformations of quadratic functions. And we're going to explore that in a minute, but first, I want to show you some transformations on Desmos. So let's take a look at our parent function for all quadratic equations in Desmos. As you can see, I have the parent function graphed here. It is black and it is a dashed line. We're going to be doing the same thing in our notes pretty soon. And underneath that, I wrote vertex form of a quadratic function. And you will notice that I have A, I have H, and I have K all right here. And those things are going to transform that parent graph in one way or another. The good news is that all of these three items, the A, H, and K, are going to change or transform your parent function in the same exact way they changed them in Chapter 1. So if I just click on this, it will show you a solid version of the graph, but we're going to move this graph to show you what A, H, and K does. So let's move K. If I move K to a positive number, it's going to have that effect of adding something to your function, and it's going to slide it up. So this is a translation up. And if I take away, so if K is negative, it slides it down. Let's change that back to 0. H is going to have the effect of moving left or right. Now, if H is positive in your function, it will say minus the number. So if I move this to 3, 4, 5, see how it slides it to the right? But this is actually going to be x minus 5 in your function. If I slide it to the left, it'll be negative, changing your function to x plus the number. So if I change it to -6, that will say x plus 6. It has slid it to the left. So those are translations left and right. Now A is the number that is multiplied to your function, and it's a little bit more complicated because you can have two different transformations with A. If A is negative, it automatically means you're going to reflect it over the x-axis. Okay, so as soon as it becomes negative, see now 0 just makes it a flat line. Okay, that's a constant, it's no longer quadratic. But as soon as it turns negative, see what it does? But it also reflects it, and it either stretches or shrinks. So the stretches or the shrinks come into play of the value of A. So if the absolute value of A is greater than 1, it's going to stretch it. If the absolute value of A is between 0 and 1, it will shrink it. And what that does is it changes the distance between your y values. So if you have a shrink, it's going to actually push your y value closer. It's going to shrink it or compress it. I like the word compress better. But if you multiply by something greater than 1, it's going to pull those y values away from your x-axis. Now, I'm just talking about a vertical stretch and shrink. We're not talking about horizontal. Moving back to the notes, as you can see, it gives you the parent function right here. Your parent function is just x squared. You don't have anything multiplied, added, or subtracted to any parts of your function. And please make a note where your points are. You start, or your vertex starts at 0, 0. You have your first point when x is 1, y is 1. But when x is 2, y is 4. And the reason why is because when you square the 2, you wind up with 4. And you see you have symmetrical points on the other side. Something that is not on your graph is your line of symmetry. We'll talk about that a lot later on in this chapter, but not so much today. That's just going to help you make your graphs a little bit quicker because your graph is symmetrical. So take a second and highlight these three letters here, your A, your H, and your K. Those are all of the things that will change your parent function into how it appears later on. So right here, I also have added in function notation between the descriptor and the pictures. So if you look over here, this is a vertical translation. So if it's going to translate, this is going to go up or down. So you can see here, you're adding to the function. So you can maybe write the word up if you want to. And then over here, you are going to write the word down. And it kind of just tells you if k is negative, it will shift it down. So in this case, it's -1. Over here, k is +1, so it shifted it up 1. We still have translations. It is horizontal though. That means it's going to go from the left to the right. Notice that in your function notation, you are subtracting from the x, not the function. So the location of what you're adding and subtracting matters. So this is going to move it to the right. And plus h to the x will move it to the left. And you should be able to see all of this stuff without using Desmos. Just look at the function or the function notation. Okay, next up is a reflection, and you know that it is going to reflect if you see a negative that has been multiplied to the function or to the x. In this case, it is going to reflect over the x-axis because you're multiplying the function by a -1. The other type of reflection is a reflection over the y-axis. See that it's changed its location. So you're only multiplying the x times -1. And unfortunately, you really can't see this on a graph. You can only see it written in the equation itself. So you can see it right here, but if you multiply it out, it's going to look literally the same as your parent graph. So it does kind of rotate over that y-axis. So pay attention to where the negative is. All right, last but not least, we have our vertical shrink. Notice the location of A. See how it is multiplied? It's not negative. It's going to be between 0 and 1. So if you multiply anything between 0 and 1, that means that it is going to shrink it. And it's going to actually, you can see the arrows here, it's going to push all of those y values toward the y-axis, because your distance between your y values and your x-axis is getting smaller, and it's going to look like it's pushing toward the x. And then you have your vertical stretch. So instead of shortening the distance between your y values, you're actually making them longer. So you multiply by 2, you're going to double the distance between your y values and the x-axis, and it looks like you are pulling it away, and it makes the graph appear skinnier. So we're going to put all of this knowledge into practice. Now, you're not going to want to use Desmos when you do these problems. That's not the intention. Anybody can type in a function and copy it on a graph. What you need to do in this lesson is try to do it without using Desmos. You've got to use your transformations only. And it's a little easier than you think it might be. So let's go ahead and highlight. Your vertex of your parent function is always going to be 0, 0. We're going to practice graphing your parent function, and then we're going to apply transformations to that parent function, okay? Your vertex is only going to change if you have any kind of shifting up, left, down, or right. Reflections won't change it. Stretches and shrinks won't change it. And we'll see that in a second. If you have multiple transformations, okay, you're going to want to go in order. You're going to want to reflect it first, whether that be over the x or the y. Then you're going to want to stretch or shrink. That's going to affect your y coordinates. And then you're going to move things up, down, left, or right last. Okay, so question number 1, it says to describe the transformations of f of x equals x squared. That is our parent function represented by g of x. Now I want you to notice we have some changes here and we have a change here. So we need to write down what each of these, what they're going to do. So this one right here, this plus 4 is going to make it translate, so it's going to slide left 4. Okay. And this other one right here is going to translate it down 1. I don't have any stretches and I don't have any shrinks. I don't have any reflections. So if I just go ahead and translate left 4 down 1, that should be my final result. So how am I going to do that? Well, what is the vertex of your parent function? Let's go ahead and start with that. So what we're doing right now is we're graphing our parent function and we're going to use a dotted curve. So I'm going to use, let's do pink, I guess. So I'm going to put a point right here. This is the parent function. And we're going to graph all 5 points. And remember, it's symmetric. So my vertex starts here, and I know I'm going to go up 1 over 1. And then if I go over 2, I have to square that number. So over 2, up 4. And then on the other side, I'm going to match the same pattern. And I'm going to make it a dotted line because I know that I'm going to transform this. Everybody should have that parent function memorized at all times. You shouldn't have to graph it on Desmos, so try to remember those 5 points. Okay, so if you just take this vertex here and you shift it left 2, 3, 4, and down 1, you should wind up with that vertex of -4, -1. So go ahead and fill in the rest of these points. You can shift them all individually if you want to, or you can just use that pattern that you do on your parent graph and then just fill in symmetrically where they belong. Okay, and then I'm just going to label that one g of x, and this one was f of x. I know it's a long way away, but I just wanted to let y'all know that there will be 2 parts to your Chapter 2 test. You will have a section without any calculator, so you will not be able to graph, and then once you're done with that, then you have access to a graphing calculator. So it's very much like your end of course. And so when I say that you need to do this without your Desmos calculator, you definitely want to try to do this without your calculator. Okay, so this next one adds an additional transformation. I have a stretch. I know it's a stretch because it's greater than 1. So I'm going to have to deal with that first. So let me go ahead and write that down. This is a vertical stretch factor of 3. And I'll tell you what that does in just a second. The next one here is this +2 on the x-axis, or sorry, your x variable. That is going to move it to the left 2. And then we have one more here. That is going to move it up 1. So the first thing I'm going to do is I'm going to deal with the vertical stretch factor of 3. Then I'm going to do the left 2 up 1 at the same time. So it says, what is the vertex of g of x? The only thing that affects your vertex is the shifting left and right and up and down. So if it starts at 0, 0, and it moves left 2 would be -2, and then it will go up 1, so it will go to +1. So I know that my final, my g of x's should start right there at -2, 1. Let's go ahead and graph and see if that works out that way. Parent graph one more time. I'm going to use pink. So it starts out 0, 0, over 1, up 1, over 2, up 4. Same thing on the other side because it's symmetrical. And then we're going to do a dashed line. That is our parent function and our guide. Okay, so how do I deal with this stretch of 3? So you notice how it goes up 1. So instead of going up 1, if you have a stretch factor of 3, just multiply by 3. So instead of going up 1, you're now going to go up 3. 1, 2, 3. Now this one is up 4. This is a really small graph. So if I needed to graph this one, I'd have to say up 4, up 12. That's way off my graph. So I'm just going to use these 3 right now as a guide. So this one's up 1. So 1 times 3, I'm going to make that go up 3. Don't draw your line yet because you just did the stretch. So now if you want to do your translations, you're going to go left 2, up 1. So each one of these, you're going to go left 2. So 1, 2, up 1 right here. That's where it's going to be. Left 2, up 1. Left 2, up 1. Now draw your line, your curve. Okay, so it does make it more complicated. These dots right here were just guide points. I'm going to get rid of that one. But that is how you do it without a table and without Desmos. So it's not too bad. You just have to get used to it. Just make sure you go in the correct order. I just want to add one thing in case you look back at your notes and you're wondering how you dealt with this vertical stretch right here. What you do is you multiply the y coordinate by 3. So if your y coordinate was 1, then you're going to graph your new coordinate at 3. If your y coordinate was 2, you're going to graph your new y coordinate at 6. It's just tripling the distance from your point to the x-axis. That's it. So this is the last example of graphing in our notes. Same kind of concept, we just have different transformations to deal with, but this time it's a little bit simpler. I have a reflection here, and then I also have a plus 3 at the end of my function. So what do these mean? So if that negative is out in the front of my function, this means I'm going to reflect over the x-axis. And what happens is that all of your y values are just going to change signs. That's the effect of multiplying the entire function by -1. This one over here, this plus 3, is simply going to translate it up 3. Okay, so that one's not too bad. The one that you have to do first, though, is the reflection. So before I start that, let's write down what the vertex of g of x is going to be. Remember, it starts with 0, 0. So the only thing that changes it is if it's moving up, down, left, or right. It has not moved left or right, so that's going to stay 0, but it has translated up 3. So that means it's going to go up to positive 3. All right, I'm going to start out with the same parent function we did on the last two. Vertex in the middle, over 1, up 1, and then over 2, up 4, because it's squared. And then fill in your symmetric dots, and a little dashed line. And this is our parent function. So I am supposed to reflect all of these points. So I'm going to use blue again, and if I reflect them, it's going to go across the x-axis. So this is at positive 1, now it will be at negative 1. This is at positive 4, and now it will be at negative 4. 0 won't change, it doesn't have a sign. Negative 1, negative 4. So it should still be symmetrical. This is not my final form because it wants us to also move it up 3. So I'm going to take all of these blue dots and I'm going to move them up 3. So this one's going to start here. This one, 1, 2, 3 here. 1, 2, 3. I'm going to draw my line here. And 1, 2, 3. here. And if you want to go ahead and erase some of these extra little temporary dots, you can. That is your g of x. That is how you do it without Desmos. So this last part is to help you practice with your function notation. Just remember that function notation works for any type of function, not specifically just quadratics. It could work for any family of function. So if you look at part A, we have the function, but we have something subtracted from it. And if you're subtracting from the function, then that means down 2, which is a translation. On this one, we are subtracting from x. So if you're subtracting from x, it will be to the right 4. Let me do my arrows as well. That's right. And this is down. All right, third one, we have a couple of things going on here. This plus 3 is going to make it go to the left 3. And then minus 7 is going to make it go down 7. Okay, part D, I see a little negative hanging out in the front, and I also see a plus 1 to the x. So the negative, since that's in front of the function, that's going to reflect over the x-axis. And the plus 1 is going to make it go to the left 1. Part E, I have a 1/2 in the front, and then I have a negative with the x. So since the negative is with the x, it's going to reflect it, but it will reflect over the y-axis. And the 1/2 is going to wind up being a vertical shrink. And I know that it's a shrink because it will half the distance from the y-coordinate to the x-axis, and it will be a factor of 1/2. Last one, I have 3 things going on. I've got a negative, I have a 3, and I have a minus 1. So this negative out in the front, that's going to reflect it over the x-axis. This 3 is going to make it stretch vertically. So a vertical stretch, factor of 3. And then the minus 1, it's being subtracted from the x, so it will be right 1. And that's it. You have an assignment on page 68. You have several questions, but some of them are multiple choice. Just do your best and let me know if you have any questions.